Hello. In this lesson, we're going to look at exponents and exponent laws. Now, this is a question that maybe none of you have ever been asked, but would you rather have $5 million right now, or, starting with a penny, double your money every day for a month? Now, starting with a penny doesn't seem like very much money, but if we do the math, in this case, we have a penny which is $0.01, and we double it. Well, if we double it the first time, we're only going to get 2 pennies, and then 4 pennies, and so on and so forth. A month is usually 30 days. So instead of just writing 2 times 2 times 2 times 2, I can use exponents. So in this case, 2 to the power 30. That means they're going to multiply 2 30 times. And when I do that, multiply by my penny, I end up with much more than $5 million. I end up with $10,737,418.24. So if I knew exponents and I know math, well, I know which part of this would you rather would I rather. Let's look at more about exponents. An exponent is just a multiple of a term. The power is the product of these multiples. It has 2 parts. I have my base right here. So in this case, my base is 3. And I have also the exponent, or power. In this case, it's 4. So this is telling me that 3 to the 4th is actually 3 times 3 times 3 times 3, or 3 times itself 4 times. So we have 2 different formats for this. We have our exponential form right here. So this 3 to the 4th. And then we have its expanded form. So what it looks like when I expand it out. So I have 3 as my base, and I multiplied it by itself 4 times. So going on to my next page, I have an example. So let's say I have like 2 to, let's say, the 6th. So if I expand it out, it's 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5, times 2. So that's 6 times. So I plug it into my trusty calculator, 2 times 2 times 2, so it's 2, and I get 64. This also works with things that are not regular integers. So if I have some sort of variable b, and so I have b to the 4th. So that's just b, whatever it is, times b times b times b. So that's it expanded out. If I knew what b is, well then I could use a calculator, or I can multiply it in my head. So there's kind of 2 different ways. We have my exponential form, and then we also have its expanded version. Now, there are 2 laws for exponents, the product rule and the quotient rule. Now, the product rule is when I multiply powers with the same base, and that's very, very important. They have to have the same base. The exponents are then added together as a single power. So here, as a general rule, I have x to the power of a. A can be any number. And I multiply that by x to the power of b. So, same base, so I can just add those exponents together, a plus b. So for example, I have here 2 as my base to the exponent 3, 2 again to the exponent 2, which overall gives me 2 to the power 5. So I just add them together. So in that case, it will expand out to be 2 times 2 times 2 times 2 times 2 again. And that will be, I believe, 232. So that's the product rule. So I'm just going to add the exponents as long as they have the same base. And that can be a variable as well. Quotient rule is when I'm dividing powers of the same base, I'm now going to subtract the exponents. So x to the power of a divided by x to the power of b, well, that just gives me a to the negative b. So here, 3 and 3 same base, 3 to the power 4 divided by 3 to the power 3. Well, that's going to give me 4 minus 3, 1. Now this can also work even if I have like a negative integer. So let's say I have 2 to the power of 3 divided by 2 to the power of 4. So that's going to be 2, 3 minus 4 equals 2 to the negative 1. Now 2 to the negative 1, the negative just indicates that it's going to be the reciprocal. So I'm going to get 1 over 2. So the negative just means I'm going to get the reciprocal. Same thing happens if I have, like, say, 3 to the power of 2 divided by 3 to the power of 4 will be 3 to the negative 2, which is equal to 1 over 3 to the power of 2. So even though I can have a negative exponent, that just means the negative just means it's going to be its reciprocal going forward. And that's the end of this lesson.